Hello there, I'm Mikhail from the configure team. I'd like to show you something that I've built. It's a proof of concept for an idea to allow the CI user to construct the CI pipeline, which is a graph of jobs using the program. So yeah, I won't go into much detail of how we got here. Please read the README and follow the links. I just wanted to record a brief overview and show some pictures that the program generates. So problems that we are trying to solve here are well described in this blueprint that has been worked on by someone else, which I stumbled upon accidentally, recently, like a week ago. And so the problems are, these are the problems with YAML templating and CI YAML in general, versioning the templates to ensure builds are, reproducible and stable, and composition and sharing the templates, discovery of templates, maintenance, difficulties, and how to roll back, roll forward this stuff. In addition to that, LabFlow, which is the name of the prototype proof of concept, is we are trying to formalize the way data is passed between CI jobs. So currently there are artifacts, but there is no decoupling between consumer and producer, and LabFlow tries to solve that using some tricks called providers and futures. So let's just look at some code here. Here's a simple what would be a replacement for a CI YAML. We have two jobs, some arguments, and the second job actually depends on the first one, and we can try to run it, and it actually generates a graph into a file, the visualization of the graph, and here it is. So there's a bit of nesting going on here, and I'd like to explain that a little bit. So this arrow is depends on relationship. So this thing depends on that thing. Now this thing is an action. In this case, it's a run container action. So run this container image with this command line arguments, and this one depends on that one just for ordering purposes. And the yellow boxes are the steps, so-called steps. A step is a way to group multiple actions if you need to. So that becomes more interesting if we look at the library. So this file, as you can see, it loads from this file, it loads a symbol job, and that's what we use here to create those steps. These are steps. And job is defined in this file. This is the definition of job. So we use a special built-in function, part of LabFlow, to construct a job constructor. I'll define a function, because this is a special function that takes these arguments, and then when it's called, it actually calls this function, and this function constructs the action. So if we do this, we should see this in the console code 2 times because we coded 2 times. And this is the simplest thing we can have, I guess. So what's interesting here? You can see that we can define types for the arguments. And we use something called schemas to define types, and they compose this thing. Arguments is a list of each item of the list is a string, and here we consume the arguments using the context passed here, using address image, this thing passed to the front container, and so on. This is retrieving the arguments if they're there, defaulting to an empty list. So I guess this is nothing really interesting, but it's the simplest thing that illustrates the way it works. And now I can look at a more complex example. Right. So imagine we have a team, we have a team who builds container scanning functionality, and imagine they provided this as a library. It's like today we include a template to scan container images, and with this approach, we would include this as a library rather than a YAML template. Currently, we can only read it from a file, but we can teach it to fetch files from a repository or from a URL. And so this is provided by some other team, and this is how we use it to scan our images. So, yep, this builds the image, and we just depend on it to scan this image that is produced there. This is something that our team built, let's say. It comes from here, from this other file. And it's also a step. We also define arguments, types, and the implementation. Here we define a mechanism to use a special mechanism called providers and futures, 2 mechanisms, to pass the name and digest of the image to the consuming library, this one, which scans the published image. So here we instantiate a future. This function gives us a setter, a way to set the future, and then we instantiate an action which will publish the Docker image, and we tell it where to write the name of the published image by setting an environment variable to the file name of the setter, and then this actually creates an action, and we get the getter for the future by calling the setter function and passing the action to it. So, like, set gives you a getter if you give it the action that will populate the value for the setter. And we then use the getter to construct a provider. And so a provider, this one actually comes from this library. The consumer defines the contract in this case. So a provider is an object that holds data with, but not like anything. It has some structure, certain structure, and you cannot construct an invalid value. like it validates that you are constructing the correct thing, that you're setting the right attributes to the correct values. And in this case, each image is an object that has a single attribute image, and it's a future getter. So it's a way to say that image is that getter part of the future, so that you can use it to get the value that will be produced in another side job, basically in another action. So then we have image list, which has a single attribute as well. It's a list. Each item of that list is a provider, and each provider has to be the image. Type of that value has to be image. So that's what we do. We construct the image list, where images is a list of one value, and the image here is that future getter. Hopefully that's more or less clear. Then, yeah, that's our publishing job. We code here. It constructs an action in the future and returns a list of objects which contains each of those contains a getter of the container image name. So then we call this scan function, which we import from this library, and that's where these things are defined. And scan is also a step, so it can generate one or more actions, or maybe 0 actions actually, if we pass an empty list here. So to scan is a list, and each item in the list is a label. Labels are a way to refer to another step, so to declare a dependency. So here scan depends on this push image one, this thing. So each label has to provide the image list. So if you depend on something that doesn't return this, it will not. It will detect that and will error out. And also we have an attribute that configuring this scanner, whether it should scan images in parallel or sequentially. And this scanner implementation, which is what will be called, it's like pretty straightforward. It scans the list, this list to scan, you just iterate, and then in each item of the list, we take the value of image list, and then we iterate this images attribute, and for each image in that list, we create an action to scan it. So this is the Docker image that will be used. And we pass the name of the file where the container image, full container image address is, like the container name and digest, as a command line argument here. And we say that we depend on this list of actions, like it's just a dependency thing, and we depend on this future that produces this image. And if we don't want parallel, we set dependencies to an array, a list of this action, and we do this for each item in the list. So if we run this, we will see that this is our published container thing, and we told it to write the image name somewhere. and this is the future that depends on this action, and then this scan action that was that yellow box around it, it was produced by the scan job. It depends on this future for the value. It will use the value here in the arguments, and this is how it knows what to depend on. And let's change it to be more interesting. So let's say we have more images we want to scan. We publish more images, and we depend on all three. Parallel false should be sequential. Okay. Now we got this interesting thing here where we have push image 3 times. Each time it produces a future. And then the scan job, because we told it to be sequential, each action depends on one future for the image it will consume, and on the previous action, on the previous scan action. So this one will, images will be built concurrently, but then scanning will be done sequentially, because this one will be run first. This one cannot run because it depends on this and that. And then this one, well, you see, it depends on 2 things as well. And if we change it to parallel, we will generate a different picture. So again, we have 3 of those push steps, but then scan step generated 3 actions that don't depend on each other this time. And the graph is different. If we make a mistake here, let's do something like that. It will say that there's no step with this name. Then if we pass a value where a boolean, an integer where a boolean is needed, it will tell us that the type is wrong. So even though it's basically Python, we get proper error messages because we validate all the arguments when we are constructing the graph. We don't need to actually run the build to see that there is a problem, like your environment variable is a string of characters when it should be an integer, a string with an integer, let's say, or in our boolean an integer, and so on. So doesn't fix all the problems, doesn't prevent all the problems, but it's a good thing, I think. I think, yeah, we also get a stack trace. I think an important thing here is, well, many things, but we only have certain symbols imported from the library. So you can do whatever you want in your library, but if the consumer doesn't import that crazy thing you do here, they're not affected. So with templates, YAML templates, you get the whole thing, and that might be less than ideal. Composition works, or is possible in a better way, because it's just functions and values. You compose them. Don't need to think about merge, how maps merge, or how nested maps merge, or stuff like that, which is the case with YAML. Well, I guess this is what I wanted to show. Hopefully it's not too difficult to understand. Thank you.